Hello, friends. Thank you, everyone, for attending the talk, How to Troubleshoot 9 Types of Out-of-Memory Errors. So, friends, when we say out-of-memory error, several of us think it is there's just one type of out-of-memory error. No, actually, my friends, out-of-memory error has 9 different types. How do you go about troubleshooting each type of out-of-memory error is different. The diagnosis approach is different. The artifacts you capture is different. And the solution you come up with is different. So this talk intends to give you an visibility, a picture into it, right? Okay. Feel free to ask any questions in the chat. Okay. So let me share my screen. Friends, in order to understand different type of out-of-memory errors, first of all, you want to understand the JVM internal memory model. And this is probably the most important slide of my talk, right? Okay, so friends, let me kick off this with a question. Does Java process memory utilization go beyond XMX? Okay, so let's say we configure our heap memory size as 6 GB. Let's say I set my XMX as 6 GB. The question that I'm asking you is, will your Java process, can it consume more than 6 GB of memory? Let me repeat that. If you configure XMX as 6 GB, will your Java process, can it consume more than 6 GB of memory? How many of you say yes? How many of you say no? Friends, let's find the answer to this question. Friends, when Java memory has multiple regions. So one of the primary region is called as heap memory. So this heap memory contains the young generation and old generation. See, as a developer, I create objects, right? Say I say new account object. When I write that code, when JVM executes, that object is created in a young generation. And if it tends to live for a long period, it gets promoted to the old generation. So when you set XMX, my friends, you are actually setting the size of your heap memory. After that, there is another compartment called as native memory. Within native memory, there is a region called meta space. There is a region called meta space, right? So this is the region where the metadata information that is required to execute the code is stored. That is your class definitions, method definitions, they are stored here. Okay. This region is outside of XMX, right? This region is outside of XMX. And you set the max value of this region by specifying this property, max meta space size. Okay. And friends, and then there is another, where is the thread stored? Threads is a very integral part of application. Threads are the one which makes your application work, right? Where are the threads stored? Friends, threads are stored in a separate region in the native memory called as threads. They're not stored in this young generation or old generation or stored in metaspace. They are stored in a separate region called as threads, which is once again outside of this XMX. And then there is another region called as a code cache. So friends, the code that we write is not the actual code that gets executed by the JVM at runtime. So JVM does a lot of hotspot compilations to improve the quality of our code, quality of execution runtime. So that needs memory. That optimized code needs to be stored. That hotspot compilation needs memory. That is coming from this code cache region, right? And then there's another region called direct buffer. Say if your application uses Java native IO, Java NIO package APIs. So people tend to use Java NIO package if you don't directly manipulate the objects. In that case, those objects are stored in this direct buffer region, which is once again outside of XMX, right? And then in Java, the garbage collection is automatic, right? I just create the objects. I don't reclaim the objects. So where is the memory for doing that automatic garbage collection is coming from? They are coming from this GC region. Okay. And then sometimes if your application talks with native application like a C and a C plus through JNI, that needs memory. Where is that memory coming from? That memory is coming from this region called JNI region, which is once again outside of XMX. And friends, I'm having one more region called as miscellaneous because certain JVM vendors have some special regions for executing the code more optimally. So I'm calling it the miscellaneous region. So when you set XMX, you are actually setting the size of your heap memory. After that, there is this metaspace, threads, code cache, direct buffer, GC, JN9, miscellaneous. All of them are outside of XMX. So the answer to this question is, can your Java process go beyond XMX? Yes, it can go beyond XMX without getting out of memory error, right? Because XMX only controls the heap memory. After all these regions are there, so Java process can consume more than XMX. Okay. Okay. So now let's see, when do you get different types of out of memory errors? So friends, when your heap memory saturates, you will get the out of memory error called Java heap space, right? So when your heap memory saturates, so your heap, all the object gets built up and it's not, JVM is not able to free up the objects, then you get out of memory error. At that point, you get this out of memory error Java heap space. Friends, there is also another type of out of memory error called GC overhead limit exceeded. This error will also be thrown when heap memory saturates. So these two errors can come interchangeably, right? It can come interchangeably. So, but when any of these two errors happen, it means only heap memory is getting saturated. Okay. So the next type of out of memory error happens when your metaspace gets saturated. When your metaspace fills up, you get out of memory error metaspace. So this is a third type of out of memory error. Friends, why we need to understand these different type of out of memory errors? First of all, let's begin this question. To answer this question, let me ask another question. What is our typical response when we get out of memory error? When we get out of memory error, typical response is we increase the XMX, right? That's what we do. When you, let's say you're getting out of memory error metaspace, and now let's say you are increasing XMX. XMX means you're going to increase this heap memory. Will it address the out of memory error, the memory problem that's happening in the metaspace? No, because you're increasing heap memory, but the problem is happening in the metaspace. It's like, say, if your hand is having a fracture, it's like a doctor is treating your leg, right? So when you get out metaspace, you need to increase the max metaspace argument, not the heap memory. Okay. And the next type of out of memory error is called as out of memory error permgen. Friends, if you happen to be running on Java 7 or below versions, you will the what does the metaspace does? Metaspace is a region which got introduced in Java 8 to store the metadata information. Earlier, those information was stored in the permgen. So if you're running on Java 7 or below, that's when you'll get this out of memory error permgen. Okay. And then the next type of out of memory error is called as out of memory error unable to create new native thread. This error happens when your threads region saturates. And then the next type of out of memory error is called as out of memory error code cache is full. This happens when this code cache region gets saturated. And then the next type of out of memory is called as the direct buffer memory when this region, in the direct buff region saturates. And then say suppose if there's any memory problem happening in your native code, C++ code, you are going to be thrown this reason stack trace with native method, right? These are the errors that is getting thrown. Friends, I see the questions are coming. I will take them towards the end of my talk. Okay. Okay. So now, friends, let's have a quick demo of what simulates an out of memory error. So for this, I have put together a sample program. So this is the most typical and the most common type of out of memory error. Okay. So friends, this is a sample code. I hope everyone is able to see my screen, my Eclipse IDE. So you can see there's a memory leak demo. It has this object one. And see, look at what's happening within the start method. I'm saying grow. I'm invoking the grow operation in this object one. Let's see what's going on in grow operation. Within this object one, there is this grow method. You can see this map manager insert records is there, right? So let's go into this insert records. So this is where the actual memory leak is happening. You can see there is this my map, which is an hash map. Here in this insert records, look what's going on. There's an infinite while loop. There is a while true condition. That means the thread which enters this method will never exit. It will just keep on a loop. Let's see what's happening within this loop. Here we say key 0. That is the counter value is going to be 0. And then the large string 0. So when the thread comes first time, it's going to insert a record key 0 and large string 0 into this hash map. And for every 1,000 iterations, it just keeps printing inserted 1,000 records. So if the thread keeps on looping, this hash map is going to be flooded with these records. And when this hash map size grows beyond XMX, you are going to get out of memory error. So let me run this program. Okay. So I'm running this program. You can see it's saying it's inserted these many records. And now you see it got out of memory error, Java heap space. Right? So friends, now how will I know? See, I got an out of memory error. How will I know what type of out of memory error I got? See, here there are 9 types of out of memory errors. How will I know what type of out of memory error I am getting? Friends, the answer to that is when out of memory error is printed, look at this. When out of memory error is printed, java.lang out of memory error, after there is a colon. And after the colon, it prints what type of out of memory error it is. So in this case, heap memory is saturating, so it's printing Java heap space. Right? If it's going to be a problem is happening in the meta space, then you're going to see meta space printed. So based on what type of out of memory error you get, you go about diagnosing the problem. So far, our human eyes, we only read out of memory error because this is the main error I only focus. But after that, look at this colon and then see what's happening here. This is the most important part to tell what type of out of memory error you're getting. Based on that, your diagnosis approach should be fine-tuned. Okay. So now, so friends, when you confront this out of memory error Java heap space, friend, this is the most common type of out of memory error. Most common, probably 80 percentage or 90, more than 80 percentage of out of memory error is happening because of this out of memory error Java heap space. When this happens, what are the artifacts you need to capture to diagnose the problem? See, friends, you need to capture two artifacts. One is a garbage collection log, another is the heap dump. Why do you need garbage collection log, right? Friends, let me show you why do you need garbage collection log. Friend, this is the garbage collection behavior of an healthy application. Why do I say healthy application? You can see the memory is building up. When a full garbage collection went ran, the memory dropped all the way to the bottom. You can see once again the memory is building up and the full garbage collection even ran, the memory is dropping all the way to the bottom. You can see this beautiful sawtooth pattern. The memory is going up and down, right? If I try to draw a line connecting all the bottom points, this is going at a kind of a 0 degrees. You can see this is going at 0 degrees, right? But friends, look at this. This is a garbage collection log of an application which is suffering from a memory leak. You can see the memory is going up, that's coming down, going up and coming down. After a point, it's not able to come down at all. The memory is not able to, it's not getting reclaimed at all. You can see it is going like this and the memory is never dropping. Right? This means it's indicating this application is suffering from memory leak. Right? You can see it is, if you see the slope of this earlier graph, this is going at a kind of a 0 degrees, going at 0 degrees. Whereas if you see this graph, look at the slope. The slope is going probably at 25, 30 degrees. And after a point, it keeps on running and memory doesn't reclaim at all. See, friends, one important observation I want to share. Whenever one garbage collection event runs, it consumes enormous amount of CPU cycles because the garbage collector has to go and scan all the billions of objects which is there in memory to see what is active and what is not active. So even when one red triangle runs, it's going to have a very enormous amount of CPU consumption. You can see here, the garbage collection cycles are running repeatedly again and again and again, and the memory doesn't come down. So when this happens, your CPU will be at 100%, 1900%. See, friends, if your CPU at a 99% and it never comes down, there is a good chance your application is suffering from a memory leak. Okay. Okay. So how do you do the GC log analysis? In order to do GC log analysis, I need to capture the GC logs. How you can capture the GC log? You can capture the GC log by passing these JVM arguments to your application. If you pass these arguments, if you say in Java 9, you pass the file path, pass this flag and pass the file path, then JVM will start to write into this particular file location. So then once you have this GC log, you can use the GC log analysis tools like a GCEC to analyze and see what's going on, to upload the file and then you can see what's going on. Okay, so friends, this is why you need GC log to confirm, okay, there's a memory leak is happening. Okay, now I have confirmed, yes, memory leak is happening. What is the next step? The next step is I need to find the root cause. Which object is leaking in my memory? To do that, I need heap dump, right? So friends, so here is an open source script. Here is an open source script. You can find the QR code and here's the link. It's available in GitHub. There's no licensing attached. When you trigger this script captures your 360-degree data from your production stack, right? See, friends, just for out of memory error, you need garbage collection log and heap dump. For other type of out of memory errors, you need some more additional artifacts to be captured. And let's say for even stepping out of memory error, when a production problem happens, let's say the CPU spike is happening, then I want to capture thread dump. In fact, the number one troubleshooting artifact that you need for troubleshooting any production problem is application logs. So when you trigger this script captures 360-degree data and then presents you as one bundle file. And this runs on all the Docker, Kubernetes, OpenShift environments. So this will become very handy because a lot of times when the problem happens, we go to SRE engineers and say, oh, can you give me this data? Can you give me application log? Can you capture me GC log? So you have to work with them and then you have to give, and sometimes they may restart the JVM without taking these dumps. Then troubleshooting becomes a lot more order. So having this script, Andy, will simplify a lot of things. You say whenever production problem happens, trigger this script. In fact, you can automate it also. Then now we have the 360-degree bundle, and then you can analyze all these artifacts, which will facilitate you to get to the root cause fairly easily and quickly. Okay. Okay. So now let's do the heap dump analysis. Okay. So friends, I've captured an heap dump for this sample program we reviewed just now. So I'm going to be using uh, the ycrash tool to do the analysis, right? So you can also use Eclipse Mat type of tools also to analyze the dump. So let me upload this dump file. So I'm saying I'm uploading this tool. So this tool can be installed locally on a machine so that you can analyze and see the results instantly, because the heap dump tends to contain sensitive information, right? It contains it's kind of a snapshot of your memory. Heap dump is a snapshot of your memory. It contains what are the objects in memory, what values it contains. So if you happen to be processing credit cards, social security numbers, VAT numbers, all those sensitive information are going to be present. So so this data has to be secured and analyzed. So having this tool installed locally on your network is highly recommended, right? Okay. So now the tool has analyzed, and then it uses the ML algorithms to detect and tell exactly where the leak or where the problem is happening. See here it tells, okay, there is this hash map. This hash map is occupying 99% of memory, and this has been referenced by this object. It gives everything, right? So, but now, friends, I'm going to be showing you very effective tip of how to do the heap dump analysis, right? See, there are going to be multiple sections. It can be intimidating, but always come to the largest object section. This section shows what are the top objects in memory. What are the largest objects in memory? Friends, always the memory leaking objects turns out to be the largest. So here you can see there's this hash map, which is occupying 99% of memory. So I want to see, okay, I see this is the culprit, but I want to see what is accumulating in this object. What is making this hash map to grow to 99%? For that, what you want to do? You want to say, click on this more icon and say outgoing references. That is one of the references going outside of this object. So I click here. It went out. Here is an hash map. You can see it as a table. Here it shows all the records that we have. You can see the key, large string. What we added is visible. So you can even go to the data, what is being added. So, okay, so now I know what is causing this leak. The next step is I want to know who is keeping this object alive in memory, which is not letting it to garbage collected. So now to do that, I want to say incoming references to see who is pointing to this object, which is keeping it alive in memory. I click on this, I can see this hash map. You can see it's referenced by this map manager. See this map manager. This map manager is the class, and you can see this is the variable. You can see even the variable to be printed. Here's the variable and here's the class. Who is referencing the map manager? I can see it's being referenced by I can get to see all these information, right? Friends, equipped with this, you can find the memory leaking object, who is referencing it, and then you can go ahead and fix the problem, okay? So now, friends, let's step back. Let's come back here. So when you get this out of memory error Java heap space, what causes this problem? It's causing because of a memory leak due to a buggy code. It could be the one of the reasons. Another reason is maybe there's increase in the traffic volume. Maybe your traffic, there's a peak traffic volume, you're getting a lot of traffic. Then also you'll get this out of memory error. So how do you fix it? If it's a memory leak, fix the code that is causing it. If it's because of increase in traffic volume, increase your heap size, XMX, okay? And what are the artifacts you need to troubleshoot? You need garbage collection log and heap dump. What are the tools you need? Like to do GC analysis, you need GCEC, and to do heap dump analysis, you need EPRO or these kind of tools to do the analysis. Okay. Okay. So friends, like this, for the remainder of the deck, I'm talking about all other types of out of memory errors and what is the approach you want to take to troubleshoot, right? So this is a 30-minute slot. So I wouldn't be able to go through each and every one of them, but the slide has been uploaded, so you can look into it. So it will be coming handy. So friends, so the primary takeaway is, look at this. Say if you're going to experience Java heap space and GC override limit exceeded, you need these two artifacts, GC log and heap dump. If you are going to get out of memory error, meta space and permgen, when you get these two type of out of memory errors, you need the garbage collection log and then the verbose class log. If you're going to kill the process or sacrifice the child out of memory error, you need the D message, which is the kernel log. If you're going to get experience the out of memory error, requested array size exceeds VM limit and direct buffer memory, you need to get application log. If you're going to get out of memory error, unable to create new native threads, you need to take thread dump. So based on what type of out of memory error, what artifacts you capture differs. Right? So that's why having this kind of a 360-degree script which can capture all the data will facilitate you to get to the root cause of the problem. Okay. Okay. So friends, let me wrap this up with one effective tip. Friends, we don't know when out of memory error is going to happen. When out of memory happens, you need to capture the data at that point in time, right? So, because after out of memory error happens, the garbage collector comes and cleans up and the object goes away. So, I need to capture all these artifacts when the problem is happening. How to do it, right? To do that, there is this JVM has this special flag called as on out of memory error. So you can configure it to your JVM, and this flag you can pass any script. Like here is a script you can pass. When you configure the script, the JVM will trigger the script. This is natively supported by the JVM. And this does not add any overhead. Passing this flag does not add any overhead. And this script, you can configure this YC360 script, which is going to capture a 360-degree data and which will facilitate you to get to the root cause of the problem. Okay. And you don't have to just use this script just for memory problem. It can be used for troubleshooting any type of production problems. Okay. Thank you very much for attending this session. I hope it was helpful. I wish you all the good luck and great success in your career. Thank you.